for this session of CMG's AIxchange. We're pleased to welcome Bryan Knouse, who will present on the history and future of AI. Bryan is a software developer living in Brooklyn, New York. He is passionate about software and technology and has created solutions for companies from the smallest cafes to the largest banks. Bryan has worked with marketing agencies to build creative, impactful advertising campaigns and has worked with early-stage blockchain companies building the first applications that appeared on the Ethereum network. Please join us in welcoming Bryan Knouse.
The topic of this discussion is AI, the history and future. This is going to be a little more topical and maybe philosophical on AI, not so nuts and bolts in the weeds of what the program's algorithms and neural networks look like. I'm going to talk a little bit about a timeline in history, some of the inspiration for this talk, some of the things that I think are very interesting in the space right now, and potentially what we might be looking forward to in the future. So first, again, Amanda gave a great introduction. I'm Bryan. I've been working with computers and programming my entire life. This has naturally led me to be very interested in artificial intelligence, specifically natural language technology. And more recently, I'm really interested in the development of spaces such as data analytics, software, and machine learning. So the inspiration for all of this comes from many, many places, but I selected three that I thought would be good for anyone watching this, and three that I found particularly impactful in my life. And each of these are in a different domain and of a different professional expertise level, so I think there's something for everyone here. First is an article on the web called The AI Revolution by Tim Urban on Wait But Why. This is an amazingly well-informed article, and it's also kind of funny. So if you're looking for an easy read on an afternoon, I would highly suggest this to all skill levels, beginners and AI professionals alike. It's well worth your time, quite enjoyable. The visuals are also fantastic. The second inspiration is a talk done by Andrew Ng recently called AI is the New Electricity. He gave this talk at Stanford University. He was a professor of machine learning at Stanford University. More recently, he led a machine learning group at a large internet company called Baidu. And this talk goes a little more into the details and weeds of machine learning, but I think it's also accessible by anyone. Again, it's a YouTube video, so really accessible by all skill levels. The final piece of inspiration is a book called Superintelligence by Nick Bostrom. This touches more on the philosophical, ethical, and economic impacts of AI and what this might mean to our society. It's very deep. It reads like a research paper. So I'd suggest this for anybody who's very interested in the space or has some background on some of the techniques present, but also an excellent resource, and I'll be relying on some of his thoughts heavily throughout. All the links for each of them are present here as well. So I think an appropriate first question to address is, what is AI? And this is difficult because AI means different things to different people. I've not heard a complete definition of AI from anyone yet that I believe fully satisfies this space. Even last night, I was having dinner with an old friend and an industry veteran in machine learning. And while there's many things we agree on in AI, we still struggle to come to a common picture on exactly what AI is. So, in the absence of a widely accepted definition, I'm going to default to, I suppose, the closest thing we have to an AI overlord for a definition, Google. So Google says that anything artificial is made or produced by human beings rather than occurring naturally. It also says that intelligence is the ability to acquire and apply knowledge and skills, the brain. So our compiled definition of AI might be that it's the technology that resembles the capabilities afforded by the brain. So why are we making AI? I think the biggest answer is to help humanity. AI carries such powerful potential that it may impact nearly every corner of society. But why do we think that AI can help humanity? So I thought a nice way we can start a discussion on AI is with a programming analogy. And it's a simple if statement, and it goes like this. Assuming really any human technological progress, and also assuming that humans don't go extinct in the relative short term, we will continue to compound intelligence over time. And to be clear, I do not believe that our biological human intellect is expanding on a per capita level, though we certainly stand on the shoulders of giants. I'm referring more towards our technological digital intellect. The intellect exhibited by the machines we are creating is compounding exponentially over time. If these rather mundane assumptions hold, then it's probable that we will develop a technology called a digital superintelligence, or an intellect more capable than all of the human minds in the world combined. So, while that's interesting, why do we want a digital superintelligence? That sounds like it could go poorly. Well, we want this because digital intelligence can help us accomplish humankind's goals in mathematics, science, exploration, medicine, energy, finance, business, and war. Now, before we get ahead of ourselves discussing Terminator and Iron Man, let's temper our enthusiasm with a very brief tour through the long history of the development of AI. This exciting time period we're going through right now isn't the first hype cycle of AI. This industry has been around for decades, and even primitive AI stretch 100 years in the past. As to when AI officially began, that really depends on our murky definition of AI. What I think we can agree on, however, is that AI came to prominence as a topic of research and interest in the early to mid 1900s with the advent of machine computation. While many debate the efficacy of the Turing test as an actual test of intellect as opposed to that of human stupidity, it marks a seminal moment for the belief that one day machines may actually be smarter than us. This period culminated with a famous conference of AI researchers at Dartmouth College in 1956, where it was proclaimed that every aspect of learning or any other feature of intelligence can be so precisely described that a machine can be made to simulate it. This excitement waned with one of several AI winters and increased again with the development of expert systems, such as Deep Blue, the IBM computer that defeated the world chess champion Garry Kasparov in 1997. AI has regained momentum in the 2000s again, and in recent years, it has been driving market capitalizations for some of the world's largest companies, such as Google, Facebook, and Baidu. Now, this isn't the first time AI has been at peak hype. For nearly a century, we've been excited about the potential of this technology. In 1958, H.A. Simon and Alan Newell agreed that within 10 years, a digital computer will be the world's chess champion. Though this ultimately became reality, it took nearly 4 times as long as expected. This overzealous ambition has repeated time and time again in the industry. Most recently, Ray Kurzweil repeating even just last year that the technological singularity will occur in 2045. And for those wondering what the technological singularity is, it's loosely defined as the time when technology is far superior to humans at every potential task we would want to accomplish. In other words, a time when there's really nothing left for us to do. With that said, there's been a few problems in developing this belief we have for an artificial intelligence or an artificial general intelligence. These problems have occurred for many plausible reasons, but one I find particularly interesting is the belief that the human brain is the most complex object in the universe. Now, I'm not sure if this belief is too self-righteous coming from humans, but it's echoed by several prominent scientists, and I do find it fascinating that despite the wide availability of human brains to ponder this and experiment on, we seem to have a faint understanding of its inner mechanisms. So it would reason that trying to recreate something we hardly understand would yield the repetitive disappointment that AI hype has delivered. I feel this is identified succinctly in something called Moravec's paradox, and it goes like this. AI has by now succeeded in doing essentially everything that requires thinking, but has failed to do most of what people and animals do without thinking. So for example, multiplying 2 10-digit numbers over and over again in fractions of a second without a mistake, quite easy for a computer, pretty hard for us. But tell me this picture of a dog is not a goat and is actually a dog, incredibly difficult for a computer to do. So let's look at this problem from a more pragmatic direction. So when I was in college a few years ago, I used to drink this one particular flavor of vitamin water, and I did this for two reasons. Most of all, I found it appetizing, but also I thought that if this focus drink could do anything to help, that would be a definite value add to my studies. But I always found the writing on the side of this fascinating. It's a paragraph with words that have all the letters jumbled up. So let me read through some of it, and I promise I'm not reading from a script here. A recent study found that it doesn't matter what order the letters of a word are in. The only important thing is that the first and last letters are in the correct position. Unfortunately, that's not the case for everything in life. Sometimes the in-between stuff matters. Imagine if you only put on your hat and shoes before going out. That's why we made this product. It's got vitamin A, an important nutrient for your eyes as they focus on everything, the middle stuff included. So take a sip. No, really, take a sip. We're waiting. There. Now you have a bit of focus. So you would think, looking at this, that it would be hard to discern. But as you read through, you realize that your subconscious is actually making this task quite easy. And for those of you that are listening who are programmers, I hope we can agree that this is a great example of a challenge the human subconscious is well equipped to handle. But to create a software program that could decipher this, unbelievably difficult. So even today, we still continue this hype for what AI might be. This is what we're looking at, a Gartner hype cycle. If you're not familiar, it kind of tracks the development of emerging technologies through the trigger of innovation, a peak of inflated expectations or hype, a trough of disillusionment as people realize the challenges with it, a slope of enlightenment, and a plateau of productivity. So even as Gartner continues to predict the plateau or mature development of several AI technologies in the next several years, if we zoom in, we can see namely deep learning and conversational AI. While I agree these technologies are maturing rapidly, I'm quite skeptical we will witness their productivity plateau in only the next couple years. I feel there's still so much work to be done. So let's take a look at some latest expectations. Nick Bostrom, the author of Superintelligence, has made several predictions of his own. His view takes a bit of a more logical approach to AI, comparing it to our best understanding of the processing power of the human brain. So to our knowledge, the human brain contains about 10 to the 11 neurons. If each neuron has about 5,000 synapses and the signal's transmitted at about 200 hertz, and let's say each signal contains about 5 bits, the human brain should equal about 100 teraops of computational capacity, or about 100 trillion operations per second of computational capacity. So in Bostrom's rationale, the advent of democratized computing power of the same level will yield similar characteristics of machine intelligence. And that threshold is happening right now. So based on this understanding, in 1997, he stated that he believed that we will have superhuman intellect within the first third of this century, so something like by 2033. More recently, only about 2 years ago, Bostrom stated that before the prospect of an intelligence explosion, we humans are like small children playing with a bomb. We have little idea when the detonation will occur, though if we hold the device to our ear, we can hear a faint ticking sound. Reiterating that we expect a technological boom, it's just quite hard to predict when. So this begs the question, why is this time different? I believe this time is different, and I believe this for a couple reasons. Number one, there is a data deluge going on in society. This slide came from Mary Meeker's Internet Trends of this past year. And you'll notice a couple things that are interesting. First of all, this is a very clear exponential growth graph. It almost looks like a tidal wave of data in its growth rate. So the first is this massive and growing availability of digitized data. Also note that the percentage of structured data is also growing rapidly. In the spirit of Thanksgiving for our American viewers here, this development of more and better data is like a gigantic feast freshly prepared for our new AI machines. And the digestion of this information is what will power more advanced AIs today and in the future. The second critical change today is processing potential. So what you're looking at here is a GPU created by a company called NVIDIA that began years ago making graphics processors for video-hungry gamers and visual artists. But the company's now found itself on a kind of digital gold mine developing these chips called GPUs, the graphics processing unit. We found that these chips are, despite their original intents, far more effective at processing AI and blockchain types of activities versus traditional central processing units or CPUs. More recently, Google's TPU, the tensor processing unit, has taken an even another step forward in neural network processing architectures. These newer hardware architectures are many times faster than traditional CPUs are at training data-hungry neural networks. The third critical change of late is kind of a combination of these two, and I like to call this leveraged machine learning. So previously, machine learning researchers encountered performance plateaus in either the form of limited available data or processing capabilities that just couldn't make use of all the data. The ability to leverage an increased availability of data alongside significantly higher processing potential, especially in the cloud, has dramatically increased the performance of neural networks and machine learning. And we're seeing that those performance metrics can continue to be meaningfully improved with larger neural networks, better hardware, and more data. So if we take a step back, we can kind of look at Moore's law plotted by the availability of growing computing power available for $1,000 in a given year. So in other words, how much computing power can you buy in a given year for $1,000? Also noted here is a rough approximation of what various animal brains are also computationally capable of. So you can see we're right about here, close to 2020, at small mammal brains, and we're rapidly approaching human potential mirrored by mainstream computing. And not too long after, we'll likely reach the computational capacity of all living mankind available for just $1,000. So to readily identify the implications of this chart, I like this more layman version, I would say. The point is that with exponentially increasing computation power, it seems to reason that technological intelligence will remain stupid to us for some time, like it does now, but soon will meet our intelligence. But it would be foolish to assume it would stop there. In all likelihood, once technological intellect meets our own, it will likely and very rapidly surpass us. This is the intelligence explosion Bostrom earlier described. And I just want to comment briefly on exponential growth because it's something we often talk about in business and technology, but I feel it's quite hard as a human to intuitively grasp what exponential growth actually looks like. So here's another example some of you may have heard before to demonstrate the rapid expansion of exponential growth. It's a riddle. The number of lily pads on a pond doubles every day. It takes 30 days for the pond to be fully covered in lily pads. When is the pond half covered? The answer is day 29. In an exponential growth scenario, it takes 29 days to cover half the pond and a single day more to cover it. So, to some, a digital superintelligence may sound fantastic, but before we run away with an exponential growth machine intelligence, let's hold up for a second, because this could go very poorly for mankind. Both the late Stephen Hawking as well as more recently Elon Musk have stressed that while the positive potential for AI is massive, this could well be the technological development that eliminates our species if we don't stop to think about what we are doing. At the same time, development is slower than our imaginations lead us to believe. If you have ever spoken to an Amazon Alexa recently, I think we can both agree Terminator is going to take a lot more time. As a result of this, ethics in AI has been and is becoming a more widely discussed topic as the concerns of digital superintelligence are becoming more real. And especially so as our narrow intelligences today, Facebook's algorithms, self-driving cars, are displaying the early inklings of a changing society in undesirable ways. An interesting commentary on this is known as the trolley problem. Some of you may be familiar. It's a classical philosophy question around the ethical mechanics of an AI. The idea is that if a self-driving car is presented with a scenario where it has to decide between killing one individual or killing another to save even other lives, how does it choose who to kill? It's a question hopefully no car will ever have to choose, but it's an interesting problem to discuss. Recently, on the right here, you can see in this picture, a large survey conducted by MIT has provided actual answers, survey answers from researchers in the community to the familiar trolley problem, where we've ordered, in the event that a car has to choose, who does it choose to hit? Today, AI is available in many forms. One of, if not the most profitable applications of AI is supporting the algorithms that are serving us relevant ads through the major online networks we all visit. But other applications can be utilized by each of us today. Google Cloud, IBM Watson, Microsoft Cloud Services, Amazon AWS, among others, all provide AI toolkits that developers may take and run with to create intelligent, conversational, visual digital experiences. These platforms have democratized AI in the sense that now any developer with an internet connection can leverage very sophisticated AI toolkits. This is where I'm most excited about what is different today. Powerful AI technologies, already superior to humans in certain areas such as speech and visual recognition, are now widely available to use and leverage in the many software applications that developers around the world are coming up with. For me in particular, I'm working on 2 projects making use of these technologies. Rapid Influence is a data analytics tool that you can talk to, sort of like if you could have a conversation with Microsoft Excel instead of clicking around and typing in formulas. The other is called Project Owl, a disaster incident management system that's like a souped-up chatbot for first responders and EMS professionals. Both of these products are powered by the services provided in these cloud AI technologies. So I imagine now that the toolkits have been provided, that creativity will flourish on top of this. And this bodes well for industry, and especially for the time-saving efficiencies with clever solutions that AI will bring to nearly every corner of the enterprise. And for me, I can't wait to watch this happen. So that's all for this discussion. The deck is available at this link. Please feel free to reach out to me on email or find me on Twitter.
Bryan, thank you so much for joining us today.
Thank you all so much.